Effect of treated effluent irrigation on yield and biominerals of banana. Abstract: to assess the effect of treated paperboard mill effluent irrigation on yield and biofortification of banana, a field trial was conducted during 2002-2003 in Mettupalayam taluk of Coimbatore District, where ITC paperboard mill effluents were treated and irrigated for agricultural crops. Split plot design was adopted and replicated twice. Main plot treatments consisted of irrigations. Treatments and amendments were added in subplots. Treated board mill effluent after filtration was fertigated through drip irrigation with 75 and 50% NK for banana, while basin irrigation was done with 175% NK. Surface irrigation with river water along with 100% NK, farmers' practice, was used as control for comparison. In the subplots, amendments viz. Fly ash, biocompost, fly ash and biocompost and green manure were applied. Banana variety Robusta was raised and observations were recorded on biofortificationof banana fruits with mineral constituents and vitamins. The result indicated that fruit mineral constituents viz. Ca and Fe increased due to effluent irrigation sources, and it was maximum under basin irrigation of treated board mill effluent with 100% NK, whereas Cu and Zn were increased under effluent fertigation with 75% NK. Similarly, mineral constituents and vitamins were increased due to the application of fly ash and biocompost and green manure over fly ash alone. Keywords: fertigation, treated board mill effluent, biofortification. Introduction. Industrialization is believed to cause inevitable problem of pollution of water, soil, and air. Pulp and paper industries use large volume of water, the bulk of which is released as effluent requiring proper treatment and disposal. Since these effluent fall in borderline as saline water, they can be considered as potential source for irrigation. Gamathi and Abalsamy, 1992, 1. Trickle irrigation has the greatest potential in increasing yields of crops with significant savings in water and nutrients as compared to other conventional methods. Mohammed Haroon, 1991, 2. Brackish water could effectively be used in drip irrigation. When brackish water is applied frequently under drip irrigation, the salinity and sodicity of the soil, especially in the root zone of the crop, is maintained at low level. Fertigation is a technique that combines irrigation with fertilization through any micro-irrigation system, especially through drip irrigation. Fertigation could bring an accurate control of water and nutrients in the immediate vicinity of the root system. Slow and frequent watering eliminates wide fluctuation of soil moisture under drip irrigation, resulting in better growth and yield. Bariosafe, 1999, 3. Among the fruit crops, banana is well known for its high water requirement, high evaporative demand, high transpiration, shallow root system, poor ability to draw water from soil beneath field capacity, and high sensitivity to soil water deficiency. Thus, it requires liberal supplies of irrigation water throughout its life cycle, emphasizing the importance of correct irrigation scheduling. Fertigation has been proved to be of great success in banana in terms of water and labor saving, with increased water use efficiency culminating in early cropping and heavy yield. Santhanabosu et al., 1995, 4. And it is an environmentally safer technology which prevents groundwater contamination. Mahalakshmi et al., 2002, 5. Prabakaran, 2017, 6. reported the groundwater quality was safe due to effluent drip fertigation. Dietary constituent of over 2/3 of world population lack one or more essential mineral elements like Ca, Mg, Fe, Zn, Cu etc. The literature regarding biofortification of banana fruits due to effluent fertigation is meager. Hence this study was proposed. 2. Materials and methods. The investigation on the effect of fertigation of treated paperboard mill effluent and solid amendments on biofortification and yield of banana, besides improving soil characteristics, crop growth, quality of crop produce and groundwater quality, were carried out at the ITC Paperboard Industries Private Ltd, Mettupalayam taluk of Coimbatore District of Tamil Nadu, India. The experiment was conducted in split plot design with 2 replications, and banana, Robusta, was selected as test crop. The treatments were assigned in main plots and subplots. Irrigation treatments were assigned in main plot that consisted of 7 treatments. I1 Farmers practice as control, surface irrigation with river water, RW, plus 100% NK, I2 RW and drip irrigation, D, plus 75% NK through fertigation, I3 RW and D plus 50% NK through fertigation, I4 treated effluent, T, plus basin irrigation, Bi, plus 100% NK through soil application I5, TE and Bi plus 75% NK through soil application, I6, TE and D plus 75% NK through fertigation, I7, TE and D plus 50% NK through fertigation. Amendments were applied in subplot. 3 types of amendments were applied in the soil: A1 fly ash at 6 tons Ha1, A2, biocompost at 5 tons Ha-1, A3 fly ash at 6 tons Ha1 plus biocompost at 5 tons Ha1 plus green manure at 6.25 tons Ha1. Recommended 100% NPK is 110, 35:330 g of NPK plant 1y1. The drip system was installed as described by Udayasurian and Prabakaran 7, 2010. The entire P was applied through single superphosphate as basal dressing in the pit before planting the suckers uniformly for all the treatments. The experimental area was irrigated with river water obtained from River Bhavani and treated paperboard mill effluent from BIPCO according to the treatments. The treated effluent was neutral in reaction with high salinity, contained appreciable amounts of nutrient cations viz. Na, Ca, Mg and anions viz. Cl, SO4 and HCO3 with less sodium hazard, SAR10. The percent sodium was well below the tolerance limit of 60 and the parameters recorded were well within the range of permissible limit prescribed by the Tamil Nadu State Pollution Control Board norms, TNSPCB. The effluent was rich in microbial load with the dominance of bacteria over fungi and actinomycetes. The drip system consisted mainly of control head system, filter, dosatron, and distribution network system, main, sub-main, lateral and dripper. The equipment used for fertigation, i.e., for injection of fertilizer solution into the drip system, was dosatron, doser pump. The fertilizer stock solution was sucked from the tank installed below the dosatron by a suction tube of 1.2 m long. The injection rate was regulated by adjusting the graduated scale provided in the injector body of the dosatron. The unit was connected to the main water line on a bypass 20 mm PVC pipe fitted with 50 mm ball valve in the upstream and a non-return valve in the downstream. A 63 mm ball valve was provided in the main PVC, which was closed, allowed water to flow through the dosatron to create vacuum. Fully mature fruit samples were collected at harvest and analyzed for mineral constituents ascorbic acid and SS-carotene as per standard procedures. The data on the observation recorded and the characters studied were statistically analyzed by the procedure described by Gomez and Gomez, 1984, using Agray's software. Wherever the results are significant, the critical difference at 5% level was presented. 3 results and discussion. Ca and Fe are an important component of a healthy diet and a mineral necessary for life. The changes on Ca and Fe content of the banana fruits ranged from 18 to 58 and 1.3 to 4.2 mg 100 g1 pulp, respectively, Table 1. Higher Ca content was recorded due to basin irrigation of effluent with 175% or NK, I4, I5, whereas lower Ca content was recorded due to farmers' practice, I1. The Ca content was not significantly influenced due to amendments. Higher Fe content was recorded due to basin irrigation of effluent with 100% or NK, I4. Among the amendments, addition of fly ash, A1, increased the Fe content, Table 2. Manganese is an important metal for human health, being absolutely necessary for development, metabolism, and the antioxidant system. The Mn content of the fruits varied from 3.4 to 4.5 mg 100 g1 pulp, Table 3. There was no significant difference observed in Mn content due to fertigation treatments, amendments, and interaction effects. The Cu content of the fruits varied from 0.34 to 0.47 mg 100 g1 pulp, respectively, Table 4. The Cu content of the fruit was increased due to effluent fertigation with 75% or Nk, I7, whereas it was decreased due to basin irrigation of effluent with 75% or Nk, I5. Among the amendments, addition of fly ash and compost and green manure, A3, increased the Cu content, while incorporation of biocompost, A2, reduced it. Zinc is an essential trace element for humans and other animals. Nearly 2 billion people in the developing world are deficient in zinc. In children it causes an increase in infection and diarrhea, contributing to the death of about 800,000 children worldwide per year. The World Health Organization advocates zinc supplementation for severe malnutrition and diarrhea. In this present study, the Zn content of the fruits varied from 0.30 to 0.48 mg 100 g1 pulp, respectively, Table 5. Among the irrigation treatments, Zn content of the fruits were increased due to effluent fertigation with 75% or Nk, I6, and among the amendments, Zn content of the fruit was increased due to addition of fly ash and compost and green manure, A3. Interaction effects between irrigation and amendment on Zn were not significant. Lack of vitamin C may cause scurvy, which may eventually lead to death. In this present study, ascorbic acid content of banana fruits ranged from 7.61 to 9.91 mg 100 g1 of fruits, Table 6. Effluent fertigation with 75% Nk, I6, increased ascorbic acid content of banana fruits. Among the amendments tried combined application of fly ash and biocompost and green manure, A3, recorded higher ascorbic acid content. The study revealed that SS-carotene content of banana fruits ranged from 78-101, Re. G100 G1, Table 7. Irrigation with effluent fertigation with 75% or Nk, I6, recorded higher SS-carotene content of banana fruits. Among the amendments, application of green manure along with fly ash and biocompost, A3, recorded higher values. Fertigation treatments, I6, I7, I2, I3, recorded higher yield than basin irrigation treatments, I4, I5, and farmers' practice, I1. The amendments also had significant effect on the yield of banana. The yield obtained from the field trial varied from 43 to 144 tons Ha1, Table 8. The yield was increased, 130 THA1, due to effluent fertigation with 75% or Nk, I6, followed by I7, 123 tons Ha1, whereas it was less due to basin irrigation of effluent with 75% or Nk, I5. Among the amendments, addition of fly ash and compost and green manure, A3, increased the yield, while incorporation of biocompost, A2, reduced it. Interaction between irrigation, fertigation, and amendments was not effective in producing significant differences in banana yield. However, the highest yield, 144 tons Ha1, was recorded due to fertigation of effluent with 75% or Nk with incorporation of fly ash and compost and green manure, I6A3, while the lowest yield, 43 THA1, was recorded due to basin irrigation of effluent with 100% or Nk with compost, I4A2. For conclusion, the mineral contents viz., Ca, Mg, Fe, Mn, Cu, Zn and vitamins, ascorbic acid and SS-carotene, were higher due to fertigation of effluent with 75% or Nk. Similarly, among the amendments, application of fly ash and biocompost and green manure increased the mineral contents. This might be due to fertigation effect, and supply of minerals constantly by the effluent might have increased mineral content. The study indicated that the treated paperboard mill effluent can be used for drip fertigation without losing minerals, vitamins, and yield of banana fruits. The acknowledgement. Necessary materials provided by the ITC company for conducting the experiment is highly acknowledged.